Well, good day today. Today we're going to learn about the quadratic function. You may have covered this in Algebra 1. You may not have. Some things may be familiar. But we begin what I could officially consider as Algebra 2. So our objective today is to recognize both forms of a quadratic equation, the vertex form and the standard form. And we'll see what that is. And then we'll have to graph quadratic equations using either the vertex or standard form. And we'll be also using the vertex as the starting point. So in either case, we will have to use the vertex as the starting point. And you'll see what I mean. A couple vocabulary terms here: axis of symmetry, quadratic function, parabola, standard form, vertex of a parabola, and vertex form. All those terms will be covered in this lesson. In Chapter 3, you studied linear functions, solving a system of linear equations, graphing a system of linear inequalities. The linear function being of the form f of x is equal to mx plus b. A quadratic function is a function that can be written in the form of f of x is equal to a times x minus h in parentheses squared plus k, which we call the vertex form, or f of x is equal to ax squared plus bx plus c, which is called the standard form. But in either case, we say that a is not equal to 0. For if a is equal to 0, then we would just have a linear equation, f of x equals bx plus c, and we'd be right back where we started in Chapter 3. In a quadratic function, the variable is always squared. The table shows the linear and quadratic parent functions. Parent function meaning the simplest function you can have for that particular function. So the parent function for the linear is f of x equals x, or y equals x. When x is negative 2, y is negative 2. When x is negative 1, y is negative 1, so on and so forth as you see in the table. The quadratic function, the parent function, is f of x equals x squared, or y equals x squared. So we take the value of y and we square it. Negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1. 0 times 0 is 0, and so on and so forth. Notice that the graph of a parent function f of x equals x squared is a U-shaped curve called the parabola. You may have heard of that before. As with other functions, you can graph a quadratic function by plotting points with coordinates that make the equation true. Today we will learn to use the vertex as the starting point in graphing quadratic equations. In fact, it's almost important, essential, that you do that in order to see both sides of the quadratic function. And what do I mean by both sides? Well, let's take a look here and see. Here's an example. We have a quadratic function that's both in vertex form and standard form. So standard form, f of x is equal to x squared minus 4x plus 3, and then vertex form, x minus 2 squared minus 1. Okay. Now I want you to notice here that we have something called the axis of symmetry. And that axis of symmetry is sort of like cuts the quadratic function right in half. Okay, the left side is a mirror image of the right side, or vice versa. Right? What else do we notice about this function? Some things we'll have to be worried about. Okay, as we go to graph, it's always nice to be able to graph particular points. One point we'll be concerned about is the y-intercept. The y-intercept is when x is equal to 0. To recall, the y-intercept, yn, is when x is equal to 0. Okay, so if I were to find the y-intercept, I'm using the standard form. I'll use the standard form. Okay, we just said x is equal to 0. So we have f of 0 equals x squared minus 4x plus, oops, I forgot to substitute in 0. Okay, x is 0. So we have 0 squared minus 4 times 0 plus 3. And that will give us 3. And as you can see on the graph, there's the y-intercept, the value of the function when x is equal to 0. It's called, all right, so we see that we have the axis of symmetry. It's the line that sort of splits the graph right in half. And then we also have what's called the vertex there. Okay, now let's look at the general equation for a quadratic function in standard form, in vertex form, I'm sorry. So let's see here. Here it is, the general form of a quadratic function in vertex form. F of x is equal to a times x minus h squared plus k, where a, h, and k are some fixed numbers and x is the variable. Okay? Now, why do we consider this vertex form? Because this here, h and k, will give us the vertex of the quadratic function. H and k is called the vertex. It is the minimum or maximum y value of the function. So as you see right here, the minimum value, the y value there is negative 1. X is 2. So my vertex, looking at this equation, f of x is equal to x minus 2 in parentheses squared minus 1, well, the vertex is going to be 2 and negative 1. H is 2 and k is negative 1. That is my vertex, and we can see that right there on the graph. Okay, so the vertex will give you the maximum or minimum y value of a quadratic function. Very easy to see what it is looking at the vertex form. Okay, a mistake students will generally make, because they see that x minus 2, and they think, oh, the h value is negative 2. That is incorrect. The function says that you take x and you subtract h. Okay, so I'm subtracting 2, x minus 2. Had the function been this, and this is a common mistake students will make, f of x is equal to x plus 2 squared minus 1. H here would actually equal negative 2. Negative 2. K would still be negative 1. K would still equal negative 1. And why is h negative 2? Because the function says you take x and you subtract h, and h is negative 2, and then you square that minus 1, so that would be x plus 2 squared. So don't make the mistake, okay, of saying that h is negative when it's actually positive, or saying it's positive when it's actually negative. Remember, you are subtracting h. Okay. Standard form. And again, my vertex is the line that cuts the parabola in half. We will say that the vertex, the axis of symmetry, I meant to say the axis of symmetry is the line that cuts the parabola right in half. So we will say that the axis of symmetry is x is equal to 2. That's where the parabola is cut right in half. So that's the axis of symmetry. Again, we're going through all of the terms here. So that was graphed using vertex form. All right, so generally, if we have a quadratic in vertex form, it's easy to graph. We start at the vertex. That way, we'll see both sides of the quadratic function. So this is what I mean. Notice here that my vertex is 2, negative 1. X is 2, I get y is negative 1. So that's where we start. Okay, so when we're graphing these, we'll start at the vertex there. And then what we do, we go 2 points to the left and 2 points to the right. So x values, 2 to the left and 2 to the right. And then we substitute in the values of x into the function to derive the other values. So as you see, when x is 0, you get y is 3. When x is 1, you get y is 0. We already know the vertex. And then when x is 3, you get y is 0. And when x is 4, you get y is 3. Now, again, I think I mentioned that this graph has symmetry, axis of symmetry. And you can certainly see that in the table. Okay? Because at x is equal to 1, you get y is equal to 0. But also know that's the same value for when x is equal to 3. Okay? The graph is symmetrical. The left side will look like the right side. Likewise, when x is equal to 0, you get y is equal to 3. But that's also the value when x is equal to 4. Okay, again, because of symmetry. So it's really kind of easy when you have the vertex form and you're graphing. Okay? You already know the x and y value from the vertex form. Okay, again, the vertex being 2, minus 1. You already know that. And so then when you begin your table, that's where you begin. You go 2 to the left and 2 to the right. And all you're really doing when it's in vertex form, all you're really doing is just calculating two values there. The 2 to the left or the 2 to the right. Because then you can use the same y values for the other two x's on the other side of the vertex. Pretty easy to do. All right? So in vertex form, it's easy to graph. You know where to start. Okay? In standard form, it's a little different. See, you don't know where to start there. But nonetheless, the vertex form and the standard form of the equation will still give you the same values. They're the same. They're identical. So notice when x is equal to 0, when x is equal to 0 in standard form, I still get y is 3. When x is 1, I still get y is 0. When x is 2, I still get y is negative 1. Doesn't matter. It's the same as we got when we were working with vertex form. We will learn how to go from vertex form to standard form and from standard form to vertex form. That's a very important part of this chapter. Okay? But let's say here, and you'll have these problems for homework, you're given just the standard form. Okay? Then how do you know where to start? How do you know where to start? You have to find your vertex. That's what you have to do. So let's see here how to do that. Okay? So here we have properties of a parabola. And this is introduced in 5.2. But as usual, we have to combine lessons, or two sections in one because we're moving pretty fast. But let's look at the properties of a parabola. Okay? For f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a not equal to 0, the parabola has these properties. The parabola opens up if a is positive. Okay? If a is positive, we say we have a happy graph. Okay? And if a is negative, it opens downward. We say if it's negative, the graph is sad. Okay? But the axis of symmetry, because that's what we want, and then we also want the vertex, because we need that to be able to graph. The axis of symmetry is a vertical line x is equal to negative b over 2a. Okay? And we'll see that. So let's think back to middle school. Okay? And you were in math class. Remember the song, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So you can kind of see where that negative b over 2a comes from. It comes from the quadratic formula. Minus that. Okay? So that's how we find the axis of symmetry. So let's assume that you were given this problem for homework and you had to graph. You need to start at the axis of symmetry, or the vertex. So again, we find the axis of symmetry. So in this problem, a equals 1, b equals negative 4, and c equals 3. Okay. All right, so the axis of symmetry is x is equal to negative b over 2a, so it's equal to negative. B is negative 4 over 2 times 1. It's equal to 4 over 2. It equals 2. Okay, so the axis of symmetry is 2. Right, that's where the axis of symmetry is x is equal to 2. Now, what do? Well, we take that value, 2, and then we just substitute it into f of x. That's what this says right here. The vertex is the point negative b over 2a. That was our axis of symmetry. We take our axis of symmetry, and then we substitute it into the original equation, and then we get our y value. So I'll evaluate that function at 2. So f of 2, well, that will equal 2 squared minus 4 times 2 plus 3, and that will equal 4 minus 8 plus 3, and that will equal negative 1. And you clearly see the vertex there. Okay, 2 minus 1. All right, so if given that problem and you had to graph, that's what you would do to find the vertex, the place you start. And then in completing a table, you'd start at the vertex like they did here. Let me highlight that. Okay, so blue, that's my vertex there. You start there, And then you would choose 2 points to the left, 0, 1, and 2 points to the right, 3, 4. And then you would use the standard form to evaluate the point 0, 1 and use symmetry to get the point 3, 4. Okay, so that's what you do. Find the axis of symmetry, substitute the axis of symmetry into the function. To find your y value, you then have your vertex, and then you take your vertex, and that's where you begin in completing your table. 2 to the left and 2 to the right. Let's go on some more examples. Here's another example. This graph is sad. Notice that a is negative. Okay, just to go back up here. If the parabola opens downward if a is less than 0. So a is negative. It opens downward. It's a sad graph. There you see the vertex form. The standard form, and here's the vertex form. Again, what would be the vertex in that problem? Well, again, okay, well, let's look at the vertex form. Again, here, vertex form, general equation. All right, so the vertex would be, the vertex for this one here would be 3 and 1. Okay, h is positive. Remember, x minus 3. So 3, h is positive and k is 1. The axis of symmetry then is just the line x is, let me choose the blue, x is equal to 3. Okay, the axis of symmetry is always part of your vertex. There, x is equal to 3. And there you can see that the vertex there is 3 and 1. Okay. Now, given the vertex form, let's continue graphing. So you'll have to do that for homework. So again, we start at the axis, we started the vertex there. We know it was 3, and then y was 1. And then we would just go 2 points to the left and 2 points to the right. Here, the authors, they did go 2 points to the left and 2 points to the right, but they went by 2's. Okay, so 3, 1, and then -1, and then 5, 7. Okay, which is okay. You certainly can do that. I would suggest, though, if you had homework, that you would just go 3, 2, 1, and then 3, 4, 5. That would be my suggestion. All right, but they went -1, 1, 5, and 7. Okay, so then you evaluate those points for that vertex form of the equation. And again, you can see the symmetry there. Okay, so 1 is 2 units away from 3, and 5 is 2 units away from 3. We'll get the same y value. -1 is 4 units away from 3, and 7 is 4 units away from 3. We'll get the same y value. Again, symmetry. And let's just suppose we were given the standard form, and we need to be able to graph. We want to find a vertex, right? We have to start at the vertex. So again, x equals -b. X equals, here a equals -1, b equals 6, and c equals -8. Not that we really worry about c for the vertex. It doesn't come into play. So x equals -b, and b is 6, all over 2a, and a is -1. So 2 times -1. So that's going to be -6 over -2, and that will equal 3. And then again, you substitute in the value of the axis of symmetry. You substitute it into the standard form. So f of 3 will equal negative. We have 3 squared plus 6 times 3 minus 8. So we have 3 squared is 9. We take the opposite, -9 plus 18 minus 8. So that's what, -17 plus 18, and that's 1. And you can see the vertex there. So my vertex then is 3 and 1. My vertex is 3 and 1. The axis of symmetry plus what we get when we take the axis of symmetry and substitute it into the equation. And then what we would do, we would as we did before, we start at the vertex, and then we would graph 2 points to the left and 2 points to the right using the standard form. Let's continue. Here's another one. Negative x squared minus 2x plus 1, and f of x is equal to negative x plus 1 squared plus 2. Again, the axis of symmetry. That would be the line x is equal to negative 1. But let's take a look at the general form for vertex form. F of x is equal to a times x minus h squared plus k. So I want you to notice here that in this example here we have a plus 1. That means h is negative 1 because x minus a negative will be a positive. So h is equal to negative 1. And then k is equal to 2. So my vertex will be negative 1, 2. And you see it there. Negative 1, 2. Axis of symmetry, well, that's always part of the vertex. That's x is equal to negative 1. And there, that would be the maximum point. The maximum y value would be 2. Okay, the maximum or minimum always occurs at the vertex. I think the other examples we had a minimum, didn't we? That's just, oh, that was a maximum too, wasn't it? And here we have a maximum. Okay, and then to graph that again, we start at the vertex, x is negative 1, we get y is 2. We get y is 2. And then we graph 2 points to the left and 2 points to the right. And complete the table. And then graph. Again, use symmetry. Okay, use symmetry to help you graph. And again, if we were given a standard form and we had to graph that, again, we would find the vertex, the axis of symmetry. Well, you have to find the axis of symmetry first before you find the vertex. So a here is equal to negative 1, b equals negative 2, and again, c equals 1, but we really don't need it. So my axis of symmetry is x is equal to negative 2 over 2 times minus 1. So that will be, what's that, 2 over negative 2, which equals negative 1. We take negative 1 and we just substitute it into our standard form. So f of negative 1 equals negative 1 squared minus 2 times minus negative 1 plus 1. Negative 1 squared is 1, and the opposite of 1 is a negative 1. Negative 2 times negative 1 is a positive 2. And then we have plus 1. 2 plus 1 is 3. Negative 1 plus 3 gives us 2. So you see there's the vertex then. There's the vertex. X was negative 1. That's the axis of symmetry. And at the axis of symmetry, y is equal to 2. And you see it there on the graph. And then we would, again, in graphing, we would start at the vertex and then use the standard form to help you find the other 2 points. 2 points to the left, and then the 2 points to the right, we could use symmetry. All right, the last thing I wanted to go over, because some students sometimes have difficulty with this, let's say here, you may have for homework something like this, f of x is equal to negative 3x squared plus 9, for example. Well, it certainly isn't in vertex form, it's in standard form. So let's do this problem. So here a equals negative 3, a equals negative 3, but what's b? What do you think b is? Okay, well, b is equal to 0. There is no b term. Well, there is. I mean, b is 0. So 0 times any x is just 0, but b is 0. And again, we don't really need to worry about 9, but I'll write it anyway. So my axis of symmetry is x is equal to negative b, negative 0, over 2 times negative 3. Well, that's just going to equal 0. That will equal 0. And then, so that's my axis of symmetry. I have to take that value and substitute it into my equation to find the y value. So f of 0 equals negative 3. Oh, why, board, why do you want to move? So negative 3 times 0 squared plus 9. That will equal 9. My vertex then, my vertex will be 0, 9. Vertex 0, 9. And then that's where I will start. So here's x. Oh, come on. So here's x, and my equation is f of x is equal to, what was that, negative 3x squared plus 9. So I'd start at my vertex, which is 0, 9. Okay, I know that's 9. And then negative 1, negative 2, 1, 2. And so I'll deal with the 1, 2. Okay, so when x is equal to 1, I have minus 3 times 1 squared plus 9. So what does that give me? Negative, or positive 6. So negative 3 plus 9 is 6. And then when x is 2, I have negative 3 times 2 squared plus 9. 2 squared is 4, and 4 times the negative 3 is a negative 12, and negative 12 plus 9. Negative 12 plus 9 will equal negative 3. And then I know that I'll just use symmetry. So this would be 6, and that would be negative 3. And then I could graph that. Oops, I want this one. I'll graph that. So at 0, I was at 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my vertex there. So it's a sad graph. And then at 1, I'm at 6. So at 1, I'm at 6. So 1, 2, 3, 4, 5, 6. So at 1, I'm at 6. And then at 2, I'm at a negative 3. And that would be right there. Oops, I want the red. And then I have to graph the other side here. So at a negative 1, and all I have to do now is just look across. At negative 1, I'm at 6. And then at negative 2, I'm at negative 3. Again, all I have to do is look across because this is symmetrical. And then I draw my graph. Okay, so that's what you guys will be doing. You'll be graphing quadratics, either given standard form or vertex form.